Hi, I'm Dr. Laura Brown, and this is the fourth clip in a series of clips where I'm sharing the approach or the methodology that I used in a recent study where we were looking at extreme climate events related to climate change. So in the previous clips, we've talked about climate change modeling, what it was designed for. We've talked about, or we've shown how to download the data set that I used. And we also have talked about net CDF data. In this clip, I'm actually going to show how you work with the software program that allows you to work with that net CDF data. So I'm assuming that you've already seen those videos or are already familiar with those things, and now we're just going to go right to that. So because I'm using a Windows computer, I need to use an interface to be able to use the CDO operator data program. So what we first need to do is navigate to the directory where we have the CDO executable file. So I'm going to show you my directory structure here. And on the local disk, I have a climate change folder, and I have a demo folder. You'll notice the climate change folder does not have any spaces in it. It has an underscore because you can't have any spaces in the CDO program, or else it will think that you're moving on to something else. So that's just a little tip there. In the Guelph folder, I have already downloaded all of the baseline data sets, so 1960 to 1990, as well as the representative pathway 4.5 for the mid-century and the representative pathway 8.5 for the mid-century as well. And that's what I'm going to use to demonstrate how you can use the CDO software. The other thing that you'll notice is that I only have one of the baseline files, and that's RCP 4.5. It wouldn't have mattered whether I did RCP 4.5 or RCP 8.5 because this data set is the same for this time period. It's really only for the projections that it changes at all. So that's just another hint there, or tip. The CDO executable is in this folder so that you don't have to type in the whole address when you're putting your input and your output files. This way, it will just all go into this folder already. I'm going to show you here that we also in the Guelph area folder, the same thing. I've downloaded all of the files for the area. You'll see that the files are a lot bigger, and I've also got an executable of the CDO software here. What I did was once I had downloaded the zip file, I unzipped it just to this main folder and copied and pasted it into those other two. Now, when you're using, this is the command line window, and when you're using the SIGWIN software, you need to navigate to the folder that has the CDO executable. And this is how we do it. We type CD and then a space, /SIG drive /C /climate _change /demo and we're going to go Guelph area first _area. Now, you'll notice that you get a dash, bash, and then a colon. That means that you've made an error in your input. And I did that on purpose because I wanted to show you two things: how you can easily get that whole line up without having to retype it, and just change one thing. So really the SIG drive should be CYG drive. So if you just do the up arrow, the last line that you typed in will automatically come up. And then you can use the over arrow to get over to here. And then we will just correct that. So it should be YG. And now we should look. Come to the end of the line, hit enter. Now you can see that, we have a yellow path directory up top, and that's important. The other thing that I'll tell you is that you need to tell the software where you would like the output and where you would like things going. And so that's another command line that you need to type in. So you need to put PATH. Actually, I'm going to show you what happens if you don't first. So let's go CDO. We're going to go over to the documentation here. And we're going to look up in the directory how you get information on your files. This is a good way to kind of start practicing working with this and seeing actually what's in the files. So in the reference manual, if you go to information, it gives you an outline of all of the command lines and what it will tell you. And if you click on it, it will actually take you to a more complete description. So here we've got what the module does, a little bit of a synopsis of how it works. So you put in your operator. These are the two operators here that are available here. And you put in your in files. And what this does is it writes to the screen information about your files. Also, you often get an example. So to print short information of a data set, you use these commands: CDO, synfon, infile. So that's what we're going to do here. We're going to go CDO, synfon, and we're going to go to that Guelph area, and we'll just look at this first one. If you're like me and you make a lot of mistakes when you're typing in code, you want to just copy and paste that. When you're in this file, you can't paste using the keyboard. You need to right-click and do paste. So, since we're already in this directory, we're looking at the maximum daily temperature with access is the model. And we're looking at RCP 4.5, and this is the baseline data set. Now, when you hit enter, what happens is you get that bash message, meaning that command is not found. The reason that comes up is because we haven't set the environmental path. And so before you're going to be able to use this, you need to type this in as well, exactly as I type it. So capital PATH, no spaces, equals, quote, $, PATH, colon, period, colon, and end quote. Enter. Now, we'll use that up arrow again to get the same line in that we tried before and got an error, and now it works. So that's something to keep in mind because that's a common error that happens. Okay, so what we've got here, if you scroll up to the top of the page, this is giving you the file format, which is netcdf. The institutional source, it doesn't actually tell you what that is, but it gives you the coordinates. So this is just point data. It's area data. So it tells you the number of points that you have. It tells you what the lat and longs are of the box that you've used. So if you are downloading your data sets and you're interrupted, or you need to download another one you've forgotten, and you get to programming it or to working with the data and you realize you've forgotten, you can go back here and make sure that you get the right coordinates to draw your box again for the downloads. The other thing that this shows you is how many time steps are included in that 30-year period. So it's daily data, and we have 10,959 days within that period. It tells you the units, which are days. The calendar is standard. So it gives you a lot of information here. It also tells you the first data set, and if you scroll down, it will tell you the last day data set that you have as well. Okay, so that's just a little demonstration of that. So let's actually use commands and use the software. Here's the last one, sorry. It also will tell you each time that it runs a command, it will tell you how many variables it's looked at and how long it took to run that. So that took 0.09 seconds. Now, what I'd like to show you is some of the commands that are common or to get you started using this. And what I've decided to do is give you an example of how to calculate seasonal mean temperatures. Now, mean temperatures aren't really looking at extremes, but mean temperatures is a way that you can compare or see really the trend of where your area is going or what you can expect in the future. So that's what we're going to start with. In order to calculate the mean in climate data, you take the maximum temperature for the day, add it to the minimum temperature for the day, and divide by 2. And that will give you your average temperature. So in order to do that, we need to combine these two files. And CDO has something for that. So we're going to go back to the booklet here, and we are going to here we go. We're going to go back to the top. Come on. And we're going to look at merge. I'm not going to do this for everyone. I just kind of want to show you some things, and then actually after this one, I'll stop using the manual, but it just gives you an idea of how things work. So to merge data sets, let me just see here. Here we go, merge. So to merge data sets. For this, you need your operator, and really for everything else other than what I've just shown, what the information files, you really need your operator, an input file, and an output file defined in your command line. And so there's 2 different merge ones. Merge data sets, so you're merging data sets with different fields. So we're going to merge the TAS-max and the TAS-min in order to calculate the mean. There's also to merge data sets sorted by date and time, and we'll also use an example of that in a little bit. So in order to merge data sets, I'm going to show you here what you can do. So I've already typed in this into any kind of text software program, and what we've got is the telling it that we want to use CDO, so CDO first. Then we've got merge, which is our command. This is one of our input files, so that's TAS-max, RCP 45, and the baseline data. We also want to merge TAS-min, and you could merge as many files as you want, really. And then this is our output file, so TAS-max-min, the name of the model, the pathway, and then instead of putting in 1960 to 1990, I've just used the abbreviation, the 70s. So we can copy this line and paste it into here. Paste and hit run. Now, as I showed you, it gives you CDO, it gives you the command that you've used or the operator that you've used. It tells you how many values have been processed from 2 variables over, and it's doubling the time steps, and then it tells you how fast it went. We can go to our data, area data thing, sort it by the most recent, and we can see that it's just made a new file, and it's twice the size as the input files because we have 2 fields in it. Okay, we'll go back to our text editor, and you can see that I've already written the same command lines for the mid-century, and for both RCP 4.5 and 8.5. So we're going to go ahead and run those as well. And actually what I'll do is I'm just going to put a space in here and talk about the next thing that we're going to do. So we'll run these first. Actually, we'll just run them all together. The next thing that we're going to do is something that's called expression. And so in expression, what you can do is use arithmetic on variables that are in the same file. So there's other ways of doing things. I'll let you explore the whole manual on your own, but this is the way that I wanted to demonstrate. And this is a very useful tool that I've read in some of the forums that isn't really used very often, and really it helps you to do a lot of work here. So you put in CDO, you put in your expression, comma, no spaces, single quote, you name your variable, so that's tasmean, equals tasmin plus tasmax, because they're both combined now in the merged file, divided by 2. Notice that there's a semicolon and then an end quote. So if you wanted to do a number of calculations, you could string them together here. But this is a semicolon and an end quote says that I'm finished with the expressions that I'm putting in. That's all I want to do. I put in the input file that contains the tasmin and tasmax variables, yes. And then I give it a name for the output file. So I'm calling it tasmean. I have the model name, and I have the RCP, representative pathway 4.5, and that I'm still using the 70s. I've done the same thing for the mid-century for RCP 4.5 and RCP 8.5. In the second video, when I talked about naming conventions, when you downloaded your data, and I was saying it's really important when you get to this step to use the same naming convention so it's easy to write the code. This is an example of how that makes that easy. If you've used a standardized naming convention, then all you really need to do is change the RCP numbers. And so you can copy and paste the commands from before and just edit them, as opposed to having to write them all out over and over again. In this small example, it doesn't seem like much to type it all in. When I look at the expanded example, and this is all of the 12 models for all 3 time periods, you can see that it would be very time consuming and prone to mistakes to type this all out by hand. So what I did was I wrote one block of code out for the access model, and then I copied and pasted it, and I just used search and replace to pick a selection. So let's say access, and if I wanted to replace it with Maroc, I just in selection. I didn't select it, so that's not working. Say I wanted to replace this with another name. In selection, and then you hit replace all, and it will change all of those. And because the naming convention is the same, I can just change the name of the model and everything else will be fine. So I'm just going to undo that now because I don't really want that to happen. Now we'll go back here, and I'm going to run this whole thing. Control C. Go over here. I'm going to show you one thing before I paste that in. When you're doing, especially when you're doing a big block of data, it's a good idea to put this search window in with the words failed in it. That way, when the script is running by, if there are any files that fail to be completed or to run, if there's an error in your coding anywhere within that program, this failed word will be highlighted on the screen and you can go back and correct it. So we're going to paste our code. Here we go. So this one failed. And as you can see, it's highlighted, and you can look up why it failed. It's saying that this didn't open, and then you can look back into why that didn't open. Command not found. Not really sure what that's saying. Oh, that had already existed because we had made it before. So let me just go back in. Let's see if we have a failure on that. Yeah, we do have a failure on that. So I'm just going to pause you for a second and resolve this issue. Okay. So the problem was that I had already put those files or created those files, and it didn't like that I did that. So I'm just going to delete the new files, and then we shouldn't have that issue. Okay, so we're going to go back to pasting. So Control-C, copy and paste. And we're going to paste it in here, and we should be fine this time. And enter. There we go. So I wanted to demonstrate two things here. First of all, that you could copy and paste a whole block of text, and it will just run through each one in succession. And so now it's done that. The last thing that I want to show here before we go to a GIS to show what we've done is I'm just going to put in this command. So in order to get a seasonal mean, we'll go back to our book here, and we're just going to type in search, so find, that will be easier, season stats. So yearly stats, multi-year seasonal statistics. So, the information again is given up at the top here. This module computes statistical values for each season depending on the chosen operator, minimum, maximum, average. In the in file is written to the out file, and the date information is put in the output field of the date of the last contributing input field. So to compute seasonal mean over all input years, you put CDO season mean. So let's do that. We're going to put Y season mean. We want TAS mean, access, the baseline period. We want the output file will be Y sees mean. So we're looking at the yearly seasonal mean, and we're going to run this one. And again, we're going to do paste. Okay, now what we're going to do is we're actually going to look at what these files look like in a GIS. So I have a license for ArcGIS, so I'm going to demonstrate in this. I can't speak for all GIS packages, but I do also know that QGIS will work with net CDF files as well. So I'd already been working on this, and I'm just going to open this map that's already been created. I'll just take a second here. My. Here we go. So I've already imported the TAS min layer, the TAS max layer, and I'm going to show you how you do that. If you're familiar with ArcGIS, you can't just use the Add Data button. It doesn't work that way. What you need to do is there is a multidimensional tool. You want to use the multidimensional tool, which is make net CDF into a raster layer. So double click on that. It'll bring up this window. And what you want to do is navigate to your folder, so Guelph area. If you sort again by date modified, we want to look at what, first of all, we want to look at what the mean looks like. And I believe this is for the base layer. So we're going to look at the mean for the base layer, the other ones. Open. You can see that TASMean is the variable. It already fills that in by looking at the file. The X dimension is lon, the Y dimension is lat. The output raster layer will be TASMean. You want to define what the band dimension is, and in this case it's time. And that will mean that you'll be able to, each band will be 1 day of that 30-year period. And then you just hit OK. And in a second here, you'll be able to see that it's crunching the numbers to import that. We should have like a little band down here that tells us that it's doing that. Seems to be taking a little while to chug through those files. I'm just going to pause you so you don't have to wait for a long time for this. And I'll be back when it's finished. Wouldn't you know it, just after I paused you, it popped up. So it didn't really take that long after all. All right, so now you can see that this is what it looks like. So you can see the size of the files, or the size of the cells, the grid cells within the file. And I'm going to actually show you how to display this a little bit differently. So if you go to display and you look at stretched, this is so that we can look at each band. And we're going to do minimum and maximum so you can see a bit of a difference in the cells and give it the same color as what I've used before. So this color here, and apply. Okay. So mostly what I want to show you is when you run your data sets, you want to always check that before you finish your data analysis, that do a test run to see that it actually is making sense and it's showing you what you think you want to see. So I suggest just using one model, taking it out, looking at it. If you're using a GIS or you're using area, you want to bring it in to be able to look at that. If you are just using point data, look at the text file, and I'll show you how to output the format for that. So if we look at the information button here, and we look at, say, this cell here, and we look at all layers, and we'll look at that again. You can see that the TASMin layer is negative 7.1. Oops, let me just go up here. Not quite. It's the TASMean layer is negative 7.15. The TASMin is negative 8.98. And the TASMax is negative 5.33. So obviously this is January 1st because it's the first band. And you can see that the maximum temperature is higher than the minimum temperature. And the average is really just adding those two and dividing by 2. So we know now that what we think CDO is doing it, and we know now that our coding is correct. And so now we can go and build this kind of file with using those basic ones to begin with, and then copying and pasting and filling in the whole data set. Now, one thing here is I want to change this season min to Y season min so that we get the yearly one. And actually what I'll do first is we'll switch directories and I'll show you the difference in the output. So we're going to change directories. So we're going from the Guelph area to just Guelph. CD / now SYG DRIE/C/climate_change demo and just Guelph. Oops, /just Guelph this time. Okay, now you can see that we're in the right directory with the yellow lettering here. And we are going to run the first line here. So this is basically the same commands, but we're looking at seasonal mean as opposed to yearly seasonal mean. And we're going to look at what that difference is. Paste, and we let it run. Okay. Now, in order to get output when you're using point data, you can actually use this command. So CD output tab, all one word, comma, then you tell the things that you want to be written in that output file. So I'd like date, I'd like the value, which will be the mean value, seasonal mean value, and the name of that parameter. You put your input file and your output file. So let's do that. I'm going to first of all just show you what it looks like. Oops. Oh, wrong way, wrong way. No, I want copy, not paste. Select this again. And I'm just going to show you what these files look like. Actually, no. I'll just do this. Control C. So we're looking at the seasonal mean here. And I want it to print to a file that, take it out of machine language and print it in a file that I can read. So we look at paste. Enter. Okay, now if we go to the Guelph folder and we modify it by date, and we see that we have a text file here. And if we open the text file, you can see what our output is. So this is really what the model's generating. So for 1960, January is the middle of the winter season. The winter season in this seasonal data is the 12th month of the previous year, the first and the second month of the year that you're looking at, so the 1960s. And the spring is the 3rd, 4th, and 5th. The summer is 6th, 7th, and 8th. The fall is 9, 10, and 11. And so the dates in this seasonal mean file are the middle date of that seasonal period. And you can see that for each year, you have one value, which is the seasonal mean for all of the seasons. Now what we're going to do is we're going to change that code slightly. And, oops, go back here. And instead of doing the seasonal mean, we're going to do this one. So I'm going to run this, and then we'll alter that output file. Control C. We'll alter that output file to look at what the yearly seasonal mean comes out as. And copy this one. No, not that one, sorry. We'll add year to this one and year to this one. Oops. Year to this one. Copy this. Paste that here. Paste. All right, and now we'll go back here. We have the yearly mean. You can see that we have the, let's just show that why it doesn't work. So if we look at the net CDF file, you can see that it's just machine language, so it doesn't really help us. What we need to do is open the text file that we've just been, the tab delimited one. Now when you look at it, instead of getting 30 years of data with 4 averages, what you're getting is really the yearly seasonal mean. So it does all the work for you, really. And certainly if you're using a GIS, this is a faster way than using the GIS program to be able to separate all of that out and calculate all of that out. This is just showing the output, but if you wanted to, if you use that command in your area file, all of the XY coordinates would still be there and you'd get this yearly mean. So that's a good one to keep in mind, or just to demonstrate here. I think that's really all I wanted to show you here was, oh no, one thing that I do want to show. No, that's it actually. I was thinking I could show you some other examples, but what I will show you here, because the examples are a little tedious, not tedious, but time consuming to show, but I will just show you here how you can quickly change once you have all of your data set typed in. Because we decided we didn't want to use the seasonal mean, we wanted to use that yearly mean. We can just go here, go to search, replace, type in C's mean, and replace that with Y C's mean. In selection, replace all, and there it's done. Keep in mind that when you're doing your analysis, you want to do all of it together. You want to use 12 models, not just one model, or a suite of models, not just one model, to get a better idea of the projection or to be more accurate in your projection. And so you want to make sure that you do them all. Once you've run this program and got the yearly mean for all of the 12 models, you're going to want to again take the average of that to get a final value. And so that's where this merge time comes in, because when you merge the time periods, and again, we should have included this in our, just going to include that here. When you merge the time periods, I'll show you what you get when it comes out. So first of all, we'll run this whole thing. And I might pause it while it's doing that, just so that you don't have to sit through this. Control C. Although it won't take very long. Paste. I am just going to pause you so you don't have to sit through watching it run. Okay, so I ran the code, and this is the output screen. I've scrolled through it to make sure that all of the variables ran. There were no failed, there were no error messages. You want to make sure that you checked the process data after each step to make sure that everything is run smoothly before you move on to the next one, because it's a lot easier to fix any errors or to check on any data sets now than to look at it later when it doesn't make sense and have to try to comb through and go back through everything. One thing that I wanted to demonstrate here is, again, using the same naming convention. What I want to do is use that merge time command this time, because what I want to do is bring all the 12 models together and have all of their data sets together, all of the yearly seasonal means come together, and then I'm going to show you the output for that. So here I've selected the last one. I've just copied the line above. So it is the 1950s, but we want to change this RCP 445 to RCP 85. So if you just go to search, replace, we replace RCP 45 with RCP 85 in the selection, replace all, And that's it. It tells us that it's done it 13 times. So in this merge time, when I talked about merging before, we just had 2 files. You'll see here as I scroll along, I don't expect you to look at all of them, but I have all 12 models by name, the output file names here. And then the last one in the series is your final output file. So here I have yearly, seasonal, mean, all of them, meaning all 12. And then I either have representative pathway 4.5, representative pathway 4.5, and this should be baseline. So I'm just going to make this 70 because that will be baseline. Okay, so the next thing to do is to save my changes of the code and then copy these lines here and run this. So again, I'm just going to pause you for a second. Okay, so I ran the code for the merge time. And as you can see here, I've got an example of the baseline. So that would be this RCP70, I've called it. And we're looking at all the models. So we have 4 variables, one for winter, spring, summer, and fall for all 12 models. So 12 times 4 is 48. And if you look here, we've got 48 variables with 1 variable taken up for the heading. So that gives us 49. Now you can work with these data to look at what the average is over all the models for the winter period. And you can see that they're pretty close here, just by glancing at them, -6, -5, -6, -6, -5, -5, but close to -6 all the way through. Anyway, you could take this into Excel and work with this more to get the range, the mean of all of these to see how this actually works out for the baseline. Then you just run the whole thing again for any climate period. The climate periods that we were looking at were the mid-century period, so the 1950s, but you could also do it for the end of the century or any other 30-year time period. What you would do then is take the projected values and subtract the baseline values from them, and you would have the change in temperature. And this would be the change in mean temperature by season. I'll let you look at the rest of the things that CDO can do for you or how you can work with these data. This is the most recent manual, and it's very explicit as I've taken you through here. I encourage you to look more closely at this yourself. Play with some data sets first before you actually start doing your analysis. This will take you through everything that you need to know. This other book is actually one that is just looking at climate indices, looking at extremes. And so this is very useful, and I used this one and a number of these things in the report that I've just done, like consecutive dry days, to look at how many dry days there are. I'll let you look through this now that you have an idea of how it works. You can read through the description. You get a little bit of an example of what the code line should look like. And I think between what I've shown you and what this shows you, you should be able to work with these data. I think that I'll just leave it at that for now. And I thank you for watching, and I wish you luck. And that's it for now. Okay, bye.